Friday. It's also snowing, which adds like another element of my favoriteness to it. So, yeah. That is helping out. All right. So today is Valentine's Day, which I'm super excited about. I love Valentine's Day a lot. And last year I did a little presentation on differential equations of love. And this year I was like, well, like differential equations, that seems kind of hard, right? But I still really love math, and I still really love Valentine's Day. So why don't I still find some way to combine two things that I love, right? Valentine's Day and math. In case you can't tell, I'm kind of stalling with each other.
Please tell me you don't do this to Emily.
So, I know not all of you guys were here last year for my presentation, so I want to do like a little summary of that, I guess. Basically, the way that it works is that you can have two different people who are attracted to each other and different parameters, and they affect each other differently. So maybe in one case, you have two people that one person's really into the other person, and the more that other person's into them, they like that and they reciprocate it. But then the other example is that, well, that other person, maybe they like people that aren't as into them. So once someone gets really into the other person, it sort of goes back and forth. All right, I can explain it better with a graph, like most math. All right. Here we go. Beginning. There we go. All right. Oh. All right. So we got the equations of love. So last year I did differential equations. So we had like Romeo and Juliet being the example. Their loves always changing. So we got Romeo's love and Juliet's. And sometimes they both really love each other, but then maybe it like will oscillate, and maybe Romeo kind of hates or doesn't like Juliet, and Juliet still loves him. So you get it like circling around between them loving each other and not, maybe mutual hatred. Or sometimes it'll spiral, right? Sometimes you get an example where it spirals in the middle, which I call friend zone. Okay, so maybe the ideal example is that they start with like both kind of being into each other, like a crush, and then head off into like true love, which is that way. So that's ideal. Like this far direction and that far direction is like restraining order, like stop. Hatred, and we're not into that. So hopefully we can, head that way. So anyway, that's kind of what I did more math on that last year. That's sort of the basics. We've got the equations for art, which I think is awesome. So if you really want to get into this, I can send you guys this presentation. If you want to graph parts, maybe for someone special, hand a graphic calculator, but I can't make this.
Oh, I would not know what to do.
Actually, so anyway, looks pretty cute. I'll send this out to you guys. You don't need to take notes or cell phone pictures of this yet. All right, so love shows up in chemistry as well. There's some chemical equations, so shout out to the chemistry department. So we've got male plus female, right, yields a chemical bond, but I don't want to be heteronormative, so I included some other types of equations, right? We can also have male plus male can lead a chemical bond, or female plus female, so it works all different kinds of ways, but basically, right, two inputs, and then they form a chemical bond. Thought that was kind of like a cool chemistry equation for love. All right, so in 1990, this guy, Havelock Ellis, who's a Brit, said that love was equal to sex plus friendship. It's a very basic level of math. We're not doing differential equations. We're not doing like square root absolute value squared. It's just like sex and friendship. The math's kind of straightforward, but it's still an equation, so it's math. So that's awesome. All right, so in year 2000, there's this physicist named Christopher Hirata. This guy has an reported IQ of 225, which is crazy, right? One of the smartest people, right? And he said, he published The Physics of Relationships. This is his paper that he wrote, which I think is really funny. And he said that love is all about Gibbs Free Energy. And this is his equation, right? So I'm thinking, one of the smartest people in the world, and love is Gibbs Free Energy. I was like, I don't know if he's that smart. I think there's a little more to it that's saying that it's like inertia, or no, this is entropy plus minus temperature times entropy. Enthalpy minus temperature is times entropy. So Gibbs Free Energy. They use that to make traction.
Nice.
I kind of think there's more to love than that, so I wanted to keep looking for other equations, right? I kind of like some of the other ones a little better. That one's just seems a little bit too contrived. So this guy named Tony Dooley in the year 2000 came up with this equation for the optimum proposal age. So some people, right, especially around my age, are like, well, when do I want to get married? Like, that's a difficult question. And so he came up with this equation to figure out, well, what's the optimum age that you want to propose to someone that you love? Here's his equation, right? Oh yeah, okay, that makes sense. Now I got it figured out, right? So simplified it down to this, which is actually pretty straightforward. P is your initial age that you start thinking you might want to get engaged. So like maybe the youngest I'd want to be engaged would be like 22. And then N is like the oldest I'd want to be engaged, and maybe I'd do like 45, I don't know. And then, right, I'd subtract them and multiply them as constant. So when I do this equation for me, I've still got like 6 years, so not that much. So I like this one, right? There's no pressure with this one. Okay, so I've got 2 videos that I'll just bring. I'll send them out to you. Just give you sort of a quick rundown of them. This one is this guy named Kirby. He's this really high achieving, I think he's a 7th grader. He makes an equation for love that's all about the probability that this older girl will go on a date with him. And so he spends all day writing this chalkboard trying to figure out his odds. Well, I won't spoil it for you, but it's really, really funny and really cute. But the janitor is like this guy who's always trying to court him. And there was this band Together that had this song called You Plus Me Equals Us. And the chorus is You Plus Me Equals Us, let's do the calculus. Which I think is awesome. And again, we don't have time to play it. I'll send it out to you guys. I got 2 links. But I hope you guys all have a wonderful, wonderful Valentine's Day. Keep thinking about math and equations, or don't. It's fine if you do.